Welcome back to the third day of the 6th EasyBuild user meeting. This afternoon, we're starting with a site presentation from the Swiss National Supercomputing Centre. This will be from Luca Marcella. Over to you, Luca.
Thank you, Simon. So welcome everybody to the EasyBuild CSCS site update. I will go directly to the outline. Now, I will talk briefly about the EasyBuild timeline at CSCS over the past years, with an overview of CSCS HPC systems, in particular the Meteor Swiss, the production system PITSDINT, and the ALP system. And then I will mention how to customize the user builds with EasyBuild at CSCS. And I will dedicate most of the presentation to the Jenkins, the use of the Jenkins interface that we integrate with EasyBuild, and in particular, the Jenkins pipelines that we have adopted at CSCS, concluding with some final remarks for possible developments in the future. Now, the EasyBuild timeline at CSCS began more than 5 years ago, and it was, let's say, starting with an experimental Cray support developed by Kenneth with Petar Foray and Guilherme Peretti-Pezzi, that ended with the stable support for Cray systems with the 11th EasyBuild hackathon back in at the end of 2015. And in the meanwhile, we adopted EasyBuild also on the first Meteor Swiss system that had a software stack that was completely built with the EasyBuild recipes. In 2016, EasyBuild was also integrated with Jenkins and GitHub with the major PITSDINT upgrade, the flagship system at CSCS in December 2016. And following in 2018, thanks to our colleague Theophilos, Jenkins with pipelines was integrated in our software stack release process. So we now, in production, we always use the pipelines now, which are available on our GitHub production repository and can be checked quickly by all users. Now, in the past 2 years, we had some updates, like Meteor Swiss systems that was updated and still fully using EasyBuild. And then also PITSDINT, the flagship system, updated to CLE 7.0.1 and then CLE 7.0.2 at the end of 2020. I didn't have space here, but there is also this, this latest update of PITSDINT. In the meanwhile, we have a new Meteor Swiss system in production, and we have now a Cray EX supercomputing system available for early user access, selected users only, that also uses EasyBuild at the moment. So I will go now to describe the main HPC systems where we employ EasyBuild to deploy the software stack. In this slide, I show you the main features of the system. Like I already mentioned, PITSDINT, which is dedicated to the CSCS user lab, and it's the flagship system. And it features most of the nodes with a single GPU per node, a P100 NVIDIA Tesla GPU, with an Intel Haswell processor on the so-called Cray XC50 partition, while we have also a Cray XC40 partition with Intel Broadwell processors and no GPUs. The ALP system is a new system available only to early users, and it features nodes with CPUs only. It's a Cray EX supercomputing system featuring AMD ROM processors. And then the new production Meteor Swiss system, which is called Arolla and ZA, the development partition, and features 8 GPUs per node, which are NVIDIA Tesla V100 with an Intel Skylake processor. The Meteor Swiss system is actually, as I mentioned, composed by 2 partitions, one development called ZA and one production called Arolla. Both features the Intel Skylake processors and Tesla V100 that I just mentioned, And the EasyBuild software stack here is in production since January 20. The machine was in pre-production at the time. Now it's in full production. The modules here, we employed a lowercase naming system, framework, sorry, naming scheme, with few exceptions. And the exceptions are listed below. The EasyBuild custom module file that we use at CSCS for, let's say, a custom environment to build recipes. And then these two modules that are meta modules called Program GNU and Program PGI that emulates the modules that you find on a Cray environment. And they provide a modules environment in a hierarchical fashion. So only after loading one of these modules, then you unroll the underlying modules. So this is done in a sort of emulation of LMOD, because this system does not feature LMOD, but the environment modules. The new system is called ALPS, and the production partition of the system is named Eiger. This is an HP Cray EX supercomputing system. As I said, at the moment it's open only to selected users for early testing. The compute nodes of this system feature two sockets with an AMD EPIC processor, like the ROM processor in the standard naming, like commercial naming. And they interface each other, each nodes, with a high-speed HP slingshot interconnect. Now, we also provided here a software stack with EasyBuild. We have created some custom tool chains to address the new Cray environment, which is called now CPE, so Cray programming environment, instead of standard naming convention on the flagship system. And these new tool chains we have called them CPE CCE for Cray compiler environment and CPE GNU for the GNU compiler environment. The modules versions in these tool chains, in this Cray PE, are pinned to avoid the use of collections, because starting with this CPE environment, Cray started using modules collections instead of the standard module files for programming environments. The system features LMOD. It is supported officially by Cray as of the Cray PE of October 2020. And the modules are based on Lua 831. We have some scientific applications that have been built successfully there and tested with EasyBuild, and I list few of them here in the slide, which include some popular codes like Gromax, LAMPS, NAMD, Quantum Espresso. Now, PITSDINT, the flagship system, as I mentioned, it is a Cray XC system with two partitions, 50 and 40, with Intel Haswell and Broadwell respectively, and the 50 partition also holds a GPU per node, a Pascal GPU per node. Now, as I mentioned, the EasyBuild software stack is in production on the system since 2016, and it has gone through several operating system updates, and the most recent one was in November 2020 to the Cray Linux environment 7.0 APO2. We have also now in place an automated update of EasyConfig files, and I'll come to that in a while. Here is a short list of some scientific applications that we build with EasyBuild on PITSDINT. On the left side, you see the GPU-enabled one with a label with the version suffix -CUDA. On the right side, the ones that are available on the multi-core partition without GPUs. And also here, we feature popular scientific codes like Gromax, NAMD, and VASP, for instance. Now, about EasyBuild for CSCS users. So users are given EasyBuild recipes when they request software in general, except if this software is a community code that we already provide. So this is less error-prone than the manual steps, of course, and also for users, they can keep some installations for their own groups without having the whole HPC center to maintain this installation. We have on the CSCS user portal at user.cscs.ch instructions to load the EasyBuild framework at CSCS with some custom module file, the EasyBuild-custom one, that creates a specific environment. And user can adopt this framework to build their custom builds. They can clone the CSCS production project on GitHub at the address in the slide. They can customize also their own recipes with the EB custom repository environment variable. And they, of course, can use the standard EasyBuild environment variables to have their own prefix and so on and so forth. Now, let's go to the EasyBuild integration with Jenkins at CSCS. So we use Jenkins as a service for continuous integration to deploy the software packages on the systems in production and test new EasyConfig files that can be submitted by staff and also by users. We also check regularly regressions of EasyConfigs that are listed in our production files. And we now also update the production recipes in view of the systems upgrades. The project names in Jenkins that run with EasyBuild are the following. Production EB, it's the one that builds the EasyConfig files once they are in our production repository. Testing EB is triggered when there is a new pull request appearing on GitHub. Then we have the new rebuild EB that actually rebuilds, in fact, stuff, but from scratch, also checking, for instance, the download for broken links and so on and so forth to ensure reproducibility. And then we have now the update EB project that runs EasyBuild to update recipes in view of a Cray PE update on the system. So creating new toolchains and using the toolchain, the try toolchain version in order to update the recipes. So the Jenkins projects defined by the pipelines provide enhanced flexibility and also is version control that is important and runs in parallel on different systems. So it optimizes the available resources. We have, as I mentioned, a CSCS EasyBuild production repository on GitHub. You can also, as a user, submit a pull request. You can add the EasyBuild configuration files to a new branch in your fork. And then your pull request must include the dependencies. In order to create the pull request, we have some policies. Let's say the title of the request must match one of the supported systems so that it can be tested. If you work in progress, then you need to put the WIP text in the subject. And then you can test multiple architectures or single architectures at the same time on some systems, like explained here, GPU or NC for multi-core systems. And once you submit a pull request, the CSCS Jenkins project testing EB will test the build of new EasyBuild recipes. And the Jenkins pipeline script of this is available at the link in the slide. Now, this is an example of the production EB pipeline, where you see the multiple system, Dint, DOM, and Eiger listed, and green. Sometimes it's happening. It means everything was fine. Before the pipeline production EB goes on, there is a testing EB pipeline. On the left side, you see a pull request submitting on GitHub. In the subject, you see the name of the systems, in this case, DOM, Dint, Eiger, and ZA. On the right side, there is the Blue Ocean interface of Jenkins showing the pipeline triggered on different systems. So the systems that you see listed in the vertical order. And green here also, luckily. Now, I also mentioned the rebuild EB pipeline. So something that rebuilds the EasyConfig files in parallel, downloading everything from scratch. And we added a step with the Atlassian Jira integration of Jenkins in order to create automatically issues on Jira when there are failures. So you see here there is a rebuild stage, red here because something failed, and then there is the Jira stage that created the corresponding Jira issues. And then last but not least, the update EB pipeline that actually creates new EasyConfig files for the updates. So the additional step here with respect to rebuild EB is the GitHub stage. So after the successful recipes have been created and updated, they are submitted automatically to our GitHub production repository. And then the final remarks. So as usual, moving HPC software stack to EasyBuild takes some time. There is a learning curve in the users and resistance to change, but of course there are a lot of advantages, reusable, let's say, recipes for users as well. And then our perspective of EasyConfigs versus EasyBlocks We prefer to use easy configs more because they are self-contained, although we have also some custom easy blocks, but not too many. And then just to give you the highlights, so we could then deploy the new software stack with a new CRAE-X system with some custom toolchains. And especially, we can use the automated easy config updates now on our programming environment. So if you have a CRAE installation, then it's also worth going through our Jenkins pipeline scripts in order to see how we do the integration with Jira, automatic submission of the GitHub PR on our repository. And work in progress, updating hopefully also the versions and dependencies, and replacing current production with update. And in the future, use reframe step in order to check the recipes once before going in production. So I put here a slide with the useful links, and I thank you for your kind attention.
Thank you for the talk, Luca. If there are any questions, then if you're in the Zoom meeting, can you use the reactions to raise your hand and we'll unmute you. And if you're watching the live stream, then ask in the EasyBuild Slack. Kenneth, do you have a question?
Yes, I do. So I was wondering, Luca, if there are any things in EasyBuild that you're currently not happy with and from a CSCS perspective, so things that are not working as you would hope or that could be improved. So as you showed on the timeline, EasyBuild has been used for over 5 years at CSCS now, mainly on, or at least initially on Bitstained, but also on other systems. And I think you're one of the main users of the CRAE integration we have, so the integration with the CRAE programming environment and leveraging all the modules they provide and building stuff on top of that. Are there things missing there? Are there things that are not working that we could improve?
I think we are overall satisfied in the sense you've been interacting with us for, yeah, as you said, more than 5 years now. So we have been managing to integrate EasyBuild very successfully with our software stack deployment, with minor corrections and minor integrations or let's say contributions occasionally, like so Victor and Irini did in the recent past. We might have let's say new contributions. I mentioned this new system, this CRAE-X supercomputing system. So these CRAE machines names are always a bit difficult to pronounce. We went from XC, now EX. And so here, as I mentioned, the problem at the moment is still under test, but I created 2 custom EasyBuild toolchains because the current CRAE toolchains are using programming environments as modules, and unfortunately now CRAE moved to module collections instead, which made things a bit more difficult. And also, at the moment, in general, CRAE in the environment, which is not always user-friendly, they provide a kind of meta module to be able to switch for different programming environment releases, because they deploy every month a new release, like you don't want to mix them up. But unfortunately, in this new system, we don't have it yet. So that's why I mentioned that now in these new custom tool chains, we have to pin the versions of the module files, because otherwise, in general, you rely on the defaults, but then would mix things up in this situation. We are very happy though that we have LMod finally officially supported by CRAE, so that's really helpful. I'm not sure if the LMod installation provided by CRAE is error-free, in the sense I had to revert back for the tool chains to use the TCL syntax of modules, because the local LMod installation was complaining about a module swap, but this is something that I think it's a problem on the CRAE side, not on LMod. But anyway, nothing particularly relevant. And for the moment, as I said, this is still in test. So this is probably something to be, let's say, we need to contribute that maybe in the next months to the main EasyBuilders GitHub. But as usual, anyway, I put here in the links the fact that although we have a custom set of easy configs and, well, not so many custom easy blocks, we always mirror our repository under the EasyBuilders official repository. So you have the link at the bottom under EasyBuilders. There is a CSCS space where you can find all the recipes that we use on the Cray mainly. Although we have also a MeteoSwift system where we use the standard FOSS toolchain. So
the new Cray system, is that the Shasta stuff where things has changed?
Yeah. It used to have the Shasta name. Now they call it EX supercomputing system. Anyway, yes, that's that one with this interconnect and mainly AMD processors.
Okay. And do you know the motivation that why they switched to module collections for their?
No, they're not providing a reason for that. And actually, we asked, we asked to have, let's say, as quickly as possible, kind of module file to let's say, meta module, like the programming environment that we're used to in order to manage the different programming environments, but also the different releases. And they're taking some time because the system is not really production ready. So they replied that probably by March, they might get back to us. As usual with Cray, it's always a matter of pushing, and because they have, of course, I don't know, many customers, let's say. So many different needs from different sides.
Would it be helpful at all if EasyBuild had support for loading collections, as it now does loading modules for toolchains or dependencies? Because I think that would be a fairly easy thing. I think what is it called? Module restore?
Yeah.
Would that be helpful, or?
It would be helpful, probably. I think also in general for maybe in other cases might be needed. I'm not aware of other situations now, but it could be needed.
Yeah.
The only issue with the module collections is now that the pinning of the versions, because until the module collections are just loading some default module files, I think it's still not ideal to use them, but instead pin the versions, because otherwise you are mixing up the environment with newer compilers or libraries, and that can bring conflicts.
Yeah,
but definitely
want to be in full control. Yeah, makes sense. Okay, I see Victor raised his hand as well.
So it's just going to complement what Lucas said for the reply. What we need for EasyBuild, Kenneth. We need the easy stack to be implemented with all these open issues related to add more options, so that this entire framework that Lucas said about testing, putting production could be simplified. We have this production data sage script that could be easily replaced by this easy stack, but we really require that you guys provide all those open issues for the easy stack to move on. And another thing is that we would like also that if you guys could test the minus package, because for instance, like it doesn't work really well if we set default flags. So if you do EB minus package and set default, you just get the modules, but you don't get the versions, right? So,
the feature we have for creating RPMs and things like
yes.
that. You're also using that, or?
We are investigating this to use in the future.
Okay.
So, but it requires the set default to be working. But you also require set default to be working the easy stack. So all these are open issues, but it would be nice if this could be addressed. So one of the related to your talk about having manpower and addressing bug fixes. So
and I guess also maybe setting priorities a bit better. So I wasn't actually aware that you were looking so closely at the easy stack files, for example. We now see it as a nice to have also for the easy project. So it's definitely on the top of our list, but if other sites are also interested in picking up on it and waiting until the the missing features get implemented, then maybe we should push a bit more.
Yeah, because everything that Lucas said will be really, really simplified.
Okay. Sounds good. Yeah.
Okay. We'll have to draw a halt there so that we can prepare for the next talk. Thank you to Luca for the talk and Victor and others for questions.
Yeah, we can jump into the breakout room if needed. So if anyone has questions, maybe join there.